All right, line H4, learning task number 1. It's actually the fourth learning task in the H24 section, but it's the first one that's part of my line H4, and it's service maintenance procedures for three-phase service and metering. First thing that we're going to go and talk about is something that we have iterated before, and this is just the connections. The fact that all of my high voltage and low voltage, it doesn't matter what I'm dealing with, there's always going to go and be torque ratings for my different components. And we are supposed to be torquing them down. Now, I know that maybe, you don't have one of these, it seems a bit extraneous, or that you just like to tighten stuff by feel because that's what you've been taught. But there's danger to that because if we over-tighten and we go through a couple of thermal cycles, summertime heat, wintertime cool, and then high loading points, you can go and create a lot of extraneous or extra stress on that actual connection itself, which is eventually going to lead this thing to, cracking or splitting, or to potentially becoming looser than what it's going to go and have. These over here are going to be torque wrenches. If you don't use one of these, you're not doing up that connection properly. We've got a deflecting beam type, which is our first one over here, which is going to be the more that you tighten, the more that this needle is going to move along in either direction, whichever direction you're tightening in. To go and show you what your torque is, we've got this one, which has got a dial that shows you, and we've got this one over here, which you are going to go and adjust along this body to whatever the torque needs to go and be, and then it is going to go and release the head. So you're going to continue to tighten until all of a sudden you're going to hear this click that tells you that you have tightened to that torque point. It's kind of similar to the chuck that you have on almost all cordless drills, where you can go and adjust. It's like a slip one, and once it reaches a certain amount of torque, it then goes and drops out. Follow the equipment manufacturer's specifications. If you don't know what the equipment manufacturer's specifications are, you've got the piece of equipment in front of you, just look up the part number off of it, and you should have those pretty much instantly. There's so much information available to you at this point, through the wonders of the internet, that it just does not make sense not to have looked it up first. Once again, though, if you don't have that information, Canadian Electrical Code, tables D6 and D7 are going to go and tell us about them. D6 is going to be for wire binding screws. That's screws where we wrap the wire around. Connectors with slotted screws. That's going to be ones where we drive the screw into them. And connectors for external drive wrenches where they got a hex head. And then D6 is based on the AWG size of wire and the type of connection. D7 is going to go and organize torques, though, according to the types and sizes of connections. Use whichever one is going to work for the type of connector that you are looking at. The other part of maintenance on surfaces is going to be identification of loose connections. And loose connections are usually going to be indicated by hot spots that are going to be inside of your components over here. Sometimes they're not going to be inside of the components. Sometimes you're going to be able to go and see them or smell them, where you're going to go and see deterioration of the insulation, where it starts to go and brown and crack and stuff like that. Other times you're going to go and have the smell. You can actually smell the plastic itself. It has that good burnt electrical type of smell that's going to be part of it. If you open up a box and you smell that, poke around inside it, take a look, go through those connections and make sure that they're all tight. If you're in a place where you cannot go and retorque the connections because you can't shut it down, remember that you are obligated to always do electrical work dead. You're not allowed to do electrical work live except in the case of absolute emergencies. If you cannot go and shut stuff down, one of the best ways to go and figure out what's happening on a circuit is to go through with what we call thermographic or heat-sensitive types of equipment. Thermographic cameras just look at infrared heat, and they treat that infrared heat as if it were, visible light, and then they convert it into just a visible, scaled type of graphic for us. So what we see over here is a thermograph. It's a picture of the heat. So it's not an actual picture of the light. It's a picture of the heat itself. And it's got a sliding scale along the right-hand side over here. The scale is going to go and show us the coldest spot in the picture that it has measured is 51.2. The hottest spot that it has measured is some point where it's going to be 85.1. The closer something is to this dark blue over here, the closer that it is going to go and be to 51.2 degrees, and the closer that it's going to go and be to this bright white over here, the closer that this thing is going to be to about 85 degrees. Over here you see that this thing is running up close to 90 degrees. Since 90 degrees is the maximum for most of our general usage types of wires, this thing's probably not going to be fine. In fact, if it's a breaker, almost all breakers are going to be rated to 75 degrees. You can find that inside of Appendix B of your Canadian Electrical Code, where underneath 4006 it tells us that if things are tested, that they're going to go and be tested to that 75 degrees. They are expensive units, not terribly expensive. They definitely come down the last couple of years. There's a bunch of really neat ones that actually couple to your phone. FLIR makes a whole pile of them where you can use them along with your phone so that you can go and see the picture and the actual thermograph that's going to be displayed at the same time. And they're going to be useful for detecting heat. The other place that they're really useful for electrical is they're really useful for detecting places that have gotten wet. We don't like to have a lot of water that's going to be associated with electrical equipment. And so if you scan through a room and you see areas that are significantly cooler along the wall, you can actually go and see where water is seeping into walls or into installations just off of the water pattern effect itself that will show up. It literally will just be a large cool spot off of the walls. These are going to be your best bet for doing non-contact, where you don't actually have to contact these wires over here. I know for a fact that this one is going to go and be overheated, but I've never yet had to actually go and touch that live connection over there. Throw the switch off of that one, go back into it, and at that point you'd be able to go and tighten this thing down. Chances are it's just going to be loose underneath this screw over here. If I take a look at what the picture is definitely that of a couple of fuses, but those fuses end over here. We don't see that the heat is inside the fuse. We see that the heat is here on the actual connection itself. Okay, that's all we're going to go and cover for the very last section up here, which is going to be our tools and maintenance of these things. Torque values, so key. Torque values are going to go and prevent these type of things. If this one had been properly torqued, we would not be looking at this hot spot on it.